Today, we continue our investigation into the most expensive PRs for the Apache NuttX project. What do we mean by most expensive? These are the PRs that took up the most time, the most GitHub runners to run during our peak period of January and February 2026, this peak period here. So we will ignore all other PRs that were not falling into the peak period of January and February. That's why we are skipping the ones in April 2025, June 2025, and so on. In an earlier video, we looked at the most expensive PR, this one here, and we noticed that it was mostly download failures. When it tried to download dependencies from external sites, like for example, OpenAMP, Nimble Bluetooth library, MicroADB, they failed. And this triggered a lot of errors in our CI build process, which is why it took so many elapsed hours, 85 elapsed hours, to complete all the GitHub jobs for that one single PR, which is a lot. Then in another video, we looked at the second most expensive PR, this one, and we saw that it was mostly compile errors, which also consume a lot of time of our GitHub runners, over 79 elapsed hours. We noticed that a lot of the recompilation, the resubmission, due to compile errors, could have been avoided if we use this new system of testing PRs in our own repository. So hopefully all developers will now start to use this new method of compiling PRs in our own repository. So this problem shouldn't happen anymore. As for the downloads that we saw in our first PR, these download failures will be addressed by our new retry mechanism. When the build for any specific NuttX target fails, it will retry up to 5 times. This hopefully will avoid the problem of the failed downloads. It will simply retry, and after the retrying, it will work. So it will not lead to cancelled jobs, and the number of hours expended on that particular job will be a lot less. So moving on, if we are skipping all the other PRs that are not in the January and February period, we come on to a third PR here. And we shall look at this today. That's PR number 17642. If we go into the spreadsheet, okay, so I have it here, 17642. How did we create this spreadsheet? I just simply took one of the other spreadsheets. Let's say we created one earlier for 18135, made a copy of this spreadsheet, and then changed the criteria, the filter for this pivot table. If we go into edit, we can see that the PR number here has been filtered by 17642 there, and the data has been updated for that PR. Now here is the PR that we are looking at today. This is the third most expensive PR within that peak period. We are not going to blame anybody. We are not specifically finding out whose fault it is for this PR taking so much time. We are just observing the data. We are trying to see why this PR took so much time to execute in GitHub Actions. So it's not the fault of our developer for doing this. It's not the fault of anybody for causing this issue, but we wish to find out what are the technical reasons behind this. So these are the build jobs that were executed for that PR. If we go into the failed jobs, for example, failure, and we click on it, unfortunately, the log files kept by GitHub are expiring. They seem to expire after 3 months. So that's why we are doing this exercise today. We are going through the logs for those job runs that are still existing, that are still available to us. And we are doing this now at a time just before the logs expire. So this video serves as a record of why these jobs failed. And we are preserving this data because in a while, the logs will disappear and we will forever be unable to find out why they failed. So this first failure, unfortunately, we were not able to discover what went wrong. We can go to the next one and we will also see that it has expired. So instead, in order to understand the overall pattern, why this particular job failed, in spite of our missing logs, we will do it backwards. The more recent builds are in January, so the logs are still around, fortunately. So let's go in and find out what's wrong. This I color-coded as yellow because it was a download failure. Let's go in and see what happened. If we go in there, we can see that the job that failed is RIS56. Let us scroll up and find out why RIS56 failed. In a while, we can see that here, lead metal. Lead metal is part of the library that comes with the OpenAMP project. Next, the Open Asymmetric Multiprocessing Library, OpenAMP here. This job failed because it couldn't download the LitAMP library, so that's why the whole job got cancelled. Why is the OpenAMP used here? Well, it's for doing communications between subsystems in NATEX. Sometimes it's also used for QMU. When we start to communicate with some drivers like RPIO or not, we will need the OpenAMP library or lit metal. We can see that this is an RVVert target, meaning that it's talking to QEMU. So I believe it's using lit metal and OpenAMP to communicate with the emulator to invoke some kind of messaging, like for example, to access a network or to access a virtual disk. And that failed. If we scroll back up, we see yet another download error. Again, failing because of lit metal and OpenAMP. So this is bad. It tries to do it twice and it failed. Which is why it's good for us to implement a exponential backoff. We do not retry immediately after failure. We will wait up to 60 seconds. If that fails, we will wait up to 120 seconds. And again, 240 seconds and so on. So it's an exponential delay that we're waiting in between retries. And we randomize it so that this won't happen all at the same time. So hopefully with the exponential backoff and the retries, we will fix this problem permanently. Let's see, any more? Yeah, so lit metal from OpenAMP, it failed twice. And we hope to fix this in future with our retry builds, our retry system for building a CI. We are now testing it, the new system, so therefore hopefully we get some results and we can roll it out quite soon. Let us go back and look at the other failures. This failure that I highlighted in purple and pink, it's a different kind of failure. If you look at Sim02, we can see that the failure is due to this step here, install NTFC. NTFC is the new framework for running CI tests, continuous integration tests, inside our GitHub Actions. Remember that sometimes you will see CI tests running in the GitHub Actions. These are tests of NATEX functionality running within the QEMU emulator on top of GitHub Actions. So it's a virtual on top of a virtual environment. Now, in this step for install NTFC, it will download and install the NTFC framework. However, we can see that it's failing because it's trying to download some Ubuntu packages and it failed. So we can see the error here. we can see another message here that says the download failed. Here, this looks like a summary of the failures. Why is it downloading packages from Ubuntu? If we look up into the script, we can see that it's doing an apt update. And that's causing this to download packages from Ubuntu, and it's failing. These apt install for Python will also trigger a fetch from the Ubuntu packages. And in the last video, we've seen this failing also. So in general, apt update, apt install is quite unreliable. And we really hope we can minimize this, right? And potentially this could also fail. Git clone, yeah. And installing of Python packages, there is a chance that it might fail, right? So you might think that cloning a library from GitHub, it couldn't possibly fail, right? Well, we're wrong. In fact, most of our downloads are hosted at GitHub. Like we saw earlier on, libmetal from OpenAMP, that's hosted on GitHub. We've also seen cases where ESP32 runtime failed, and also for other libraries like MicroADB, device tree libraries, Nimble, MCU boot. These are all packages hosted on github.com, but yet we are failing. That's why we are trying to do this very carefully. We are doing the retry with exponential backoff, and we are doing a randomized delay. Instead of waiting strictly 60 seconds, we would wait for a random number between 1 to 60, 1 to 120, and so on. We do this because we understand that this one single job could be running in parallel. So there could be 10 of these jobs. We do not want all 10 jobs to fire off downloads to github.com at the same time. That's why we do a randomized backoff. Now, so I raised this issue with the maintainer of NTFC, and it's good that we have a response. So under this issue about initial support of NTFC, this PR here, I raised my concerns. We identified 3 instances where the installation of NTFC failed, and I was suggesting that maybe we could do exponential random backoff. And in fact, what we've just seen today, this is the 4th instance of NTFC that I've seen failing. We have a response from an NTFC NTFC maintainer. Thank you so much. So the idea is that we hopefully should move this to pip. So I'm hoping also that we do a retry for pip downloads, because pip downloads could also fail. But yeah, we'll see. NTFC moving into Docker is actually a very good solution, meaning that we don't have to download it every time. The NTFC framework should eventually go into our Docker image or NATEX, meaning that all the downloads are already in the Docker image. There's no need to re-download, right? Yeah, so this is work to be done. I'm hoping that it will be done soon so that we can monitor for any problems. So looking back, we understand that implementing a new feature into CI, like NTFC framework for CI tests, it's not really that straightforward. So it's it requires monitoring. So it's quite unfortunate that this was rolled out in January, and which coincided with this peak period. At that point in time in January and February, we were wondering what could have changed to cause this peak period. So now, thinking back in retrospect, we should have paid more attention to roll out our packages at NTFC. So all the volunteers in the NATEX CI team, we should have spent more time monitoring new packages. So the lesson we've learned is that deploying any new feature into NATEX CI is not so straightforward. Please consider standing by our NATEX CI team for doing monitoring. We have to monitor these problems because today we are seeing quite a number of NTFC download errors that happen during the peak month of January. And it sounds like a coincidence, but it might be possible that these download errors were causing our high usage problems back in January, right? So yeah, it's going to be a bit tough to do this, but we really need to. We have a very small skeleton team maintaining NetTest CI, but it's really not as simple as rolling out a new package and that's it. We need people to monitor, and we need to see if these things are failing and causing problems. Yeah, so then you might ask me, why wasn't I around in December or January to monitor this? Well, unfortunately, in December, I ran my very first marathon. I spent the next couple of weeks recovering from that horrible, horrible run. I did complete the marathon, but it was really hot and it's really bad for my body. And then in January, I signed up for another marathon. So yes, I completed 2 marathons. A bit bonkers, you might say, but hey, at least now I get to brag that I completed 2 marathons in 2 months. And I'm going for another marathon again next month in April. So yeah, this sounds a bit bonkers, but well, that's how it goes. And we need to plan these things in advance. So hopefully, maybe we shouldn't try to do this in peak periods. Now we understand that peak periods are around the Lunar New Year holiday. So this happened just before the Lunar New Year holiday when we were submitting a lot of PRs. And when we are submitting a lot of PRs, please never make changes to NetTest CI. That's a lesson that we learned. This is a very bad thing. It happened in January, February. I wasn't around. I was in the middle of a marathon race. This happened. And we didn't have the resources to figure out what happened during this peak period. So that's why it's in March now. And we are going back. We are looking through the logs. We are trying to identify what exactly happened during that period while the logs are still available. So this qualifies as a significant change to NetTest CI. It may look quite simple. We are implementing this with a few lines of script, but yet we have to be very careful and monitor this. So that's why our plan is to implement that during an off-peak period. We are now testing it, this new system, and by the time I'm back after my marathon in April, we should be able to decide whether to roll this new system or retry out to production in NetTest. And hopefully that will be off-peak, and we should be ready to handle any peak periods again, future. And of course, NTFC downloads will also need to be fixed, and we hope to be fixing this before the peak period so that we can monitor it for a while before it roll out. Next, let's look for other failures in the log here. We have another failure here. Okay, this is a Windows build error for MSPC. I'm not quite sure exactly what happened here. I'm just going to assume that it's some download issue because the error message was kind of cryptic. If we scroll up, yeah, so it's not immediately obvious what went wrong, but since I don't see any obvious compile error, I'm just going to assume that it's some kind of download error that's failing and it's causing problems. Yeah, this thing is a bit weird. I think it failed due to this libapps library. Not sure why. Yeah. So normally the MSPC libraries build successfully. The MSPC build fails complete successfully, so we don't see this kind of errors. We're not sure why, but I'll just assume that it's actually a download error. Somehow, some dependency failed and we are having this error. Let's look at this failure here. This failure here is due to a linking error. It says that the section will not fit into region flash, overflowed by 20 bytes. This, I believe, is it's compound error. That's why I flag it in orange. So this could have been something that our developer fixed before pushing this into our NUTX repository. So if we talked earlier about this way of building our CI, building our PRs in our own repos, we should use this to test our PRs in our own repo before we push them out into the NUTX main repo, right? So here comes an interesting question. So the idea is that this PR has already been submitted. It kind of succeeded earlier on, but due to some changes. So I'm assuming that if you read through the PR, all the comments in there, a particular change was requested by one of the reviewers. So it was successful, but our developer had to push it out, pushed out that PR, to push out the commit again to the PR, which triggers a rebuild, and the rebuild failed. So the interesting thing is that when our developer makes a change to the PR, the code in there, and runs it through our manual NUTX CI to test the PR in its own repo. The problem is that the PR has already been pushed. So that means our NUTX CI will already start to build the new changes, the new commits in the PR. So we'll find a situation where, yes, our developer is using this to test PRs in their own repos, but because it requires a push to the commit, that will also cause this to happen. And it will cause a failure also. So here comes the tricky part. How do we make sure that our developers can push new commits to the PRs, which will trigger to do a retest of PRs in their own repo without causing NUTX to rebuild that PR? And we want to rebuild that PR only when this thing is successful. I'm still thinking of ideas. One thing I'm thinking of is that maybe we don't build PRs in the NUTX main repo if the PR is marked as draft. So I'm thinking once a PR is successful and there are changes to be requested, and our developer needs to push out the commit for the PR, our developer should mark the PR as draft. Once it's in draft status, our NUTX CI should not build the PR. So therefore, it will not have a compile error here. That buys some time for our developer to go into this method here to build and test the PRs in their own repos, make sure that it's successful before setting a status to ready for review. So change the status from draft to ready for review. So once the PR is marked as ready for review, then we will do a job. So the question now is, how do we automate this? How do we make sure that we do not build PRs in draft mode? Well, we need to figure out. There might be a way to do this, but our problem is that we want to keep it low risk. NUTX CI is mission critical. We cannot afford to make some change to our complex CI logic and see it fail during peak periods. I have another suggestion that we could run a job on, let's say, my computer outside of GitHub that will continuously poll the status of the PRs to discover if any jobs are in draft mode. If it finds that a PR is in draft mode and there is a GitHub job running for that PR, it will kill that PR build job. So meaning, we have a looping process running on my computer, which will keep checking PR. Fetch any PRs that are in draft mode. for this particular PR in draft mode, are there any GitHub build jobs that are running for that PR? If there are GitHub build jobs running right now, kill all the build jobs. And probably post a auto reply to the PR to say that we killed a job because it's in draft mode. It's out of courtesy. So hopefully that might work, and hopefully that way of handling draft PRs fulfills our constraints. We are trying to run this outside of our complex PR scripts. We're doing something external. Hopefully it won't break anything existing. And the worst case, if our script fails, then yes, we will see jobs running even though they're in draft mode. But that couldn't hurt anything, except it may consume more resources. Yeah, so that we have some ideas on that. We are still thinking through how to do that. But potentially it could be an issue. We will see developers getting requests to change their PRs, but when they push a new commit to the PR, it will trigger automatically a rebuild. Our suggestion is that our developers should change the PR into draft mode, and we have some kind of a process which will detect that this PR is in draft mode. If it sees any build jobs running for that PR in draft mode, it will kill them. Yeah, so that's one suggestion on what we could do. I'm still thinking about it, and we'll see what we can do in a while. So the next failure is here, but unfortunately, we might not have the logs. Yeah, so there. So this concludes our analysis for this PR, the third most expensive PR in NetEx. We have seen today that we have one failure due to a compile error, which could have been fixed by using this new way of compiling and testing PRs in our own repo. We see another failure here, which looks a bit also like a compile error that could have been fixed through a testing in our own repos before submitting. And we see one MSPC error. I'm going to assume that it's a download error. It's not quite obvious what happened here. We see a MTSC download failure. NTFC download failure will be addressed by our MTSC maintainers, either moving a package to pip or moving NTFC into Docker. It's going to be tricky, so this is a non-trivial exercise. So we have to wait and see how we manage this. And of course, we have to monitor when we roll this out. Next failure that we see is OpenAMP lit metal download failed. This will be addressed by the new system that we are testing right now, the retry of CI builds. So if the download fails, it will do a retry. Yeah, so that's our summary for today. We have in total 2 build errors in orange. We have 2 download failures in yellow. And we have 1 NTFC download error in purple. Yeah. And we have solutions for all of them eventually. Yeah. The NTFC might come out. The NTSC download failure might be solved later because it's getting more complex. We need to think about putting NTSC into a Docker image. And this will need close monitoring. Whereas the download failures for other packages, we are testing them right now. And once we have the test results ready, let's say by the end of April, we should be able to roll it out in a controlled way with lots of monitoring. Today we spoke about making changes to NetEx PR, NetEx CI. Like for example, rebuilding our CI jobs when they fail, and also about changing our NTFC downloads so that they go into the Docker image. Now, then the problem comes, how will we monitor for errors after these things have been rolled out into production? So let me just spend a bit of time working on this. I have some ideas about how we could monitor this in production. These are just very early ideas, and we'll see how we can proceed to implement this idea. So remember today we have a dashboard, a NATEX dashboard that shows us the failed builds. Well, that only works for PRs that have been committed. So today we have a NATEX build farm that will build and tell us if any of the committed PRs have are failing. So with a NATEX dashboard today, this will monitor the build jobs in our NATEX mirror repo to see if any of the committed PRs are giving problems after committing, whether they have any build errors. We are also running this in the NATEX build farm. So this is a super powerful computer that keeps running builds 24/7 to compile every single target. This also runs on committed PRs. It doesn't run on new PRs that are still under review. So this will not work for PRs that have not been committed. Yet, the new systems we are talking about, our retry mechanism that we spoke today, works on PRs that are still under review. They have just been submitted but not been committed yet. NTSC downloads will also need to monitor for PRs that have been submitted but not committed yet. So let's talk about how do we monitor PRs that have been submitted but not committed yet. How do we monitor them for errors? So we want to know, for example, whether it's a compile error, whether it's a download error, and take action. So for example, if we see that after implementing the retry mechanism and we still see download errors, it means that we need to fix them right away. And something is wrong with our retry mechanism. We need to monitor this in production as people are submitting the PRs. So my idea is this: we need to have some kind of a NATEX status monitoring, right? Out of all the PRs that have been submitted, what is the status of these PRs right now? And this will be a real-time live dashboard. So, for example, we will see a table, and we will see a list of all the PRs they are running. So, for example, we have a PR number 1, 2, 3, 4, 5, and PR number 1, 2, 3, 4, 6, number 1, 2, 3, 4, 7, and so on. Right? Yes. So what do we do with this NATEX status table here? We want to see in real time what's happening to every individual PR. So, for example, we want to know how many builds this PR has triggered. So, based on our observation of the most expensive PRs, we realize that they've triggered a lot of jobs. And these are the ones we need to watch out and find out why they failed. So, for example, this particular PR, our third most expensive PR, triggered 56 jobs. That's a lot. So, we need to know of these jobs that have triggered too many PRs. So, for this PR, for example, we will see 56. And we watch out for these numbers. So this could be 56. Normally, we should just trigger, let's say, one job. So that's the ideal case. Our developer has tested this own PR in their own repo. When we submit the PR, everything succeeds. The build succeeds. And it has gone through the review, and the reviewers have not requested any changes. So that is the perfect case. We just do this one time and no more builds. So this is excellent, right? Although in reality, we'll see, well, in between. So we'll see possibly maybe 10 rebuilds. That is possibly because we have reviewers proposing changes to the PR, so which will lead our developer to recommit a PR, which will trigger more builds. Now, other things that will be very useful for us is we want to watch out for any download errors. Are there any download errors that are happening in spite of our new retry mechanism? So this will be a count. So if we see that there were, let's say, 10 download errors, well, this is a red flag. We have to go in and investigate this, right? Ideally, there should be 0. no download errors happening, because our retry mechanism, if it works, it should be 0. But if we still see download errors in spite of the retry mechanism, we have to investigate. So this download error, there could be 2 types. Maybe there could be one, we could count the number of actual download errors before retry, and after retry, are they still happening? So we might be interested in 2 numbers here. There could be 2 columns. The number of download errors before retry, and the number of download errors that still persist after retry. Because if there are any errors happening after download, if they still persist, that's something really wrong with retry logic. We need to check. Maybe we need to extend the exponential backoff, or maybe do more randomness, or something is really, really wrong with our script. We need to monitor NTFC download errors. NTFC is handled separately from our normal CI builds. Our retry script will not handle NTFC downloads, so therefore we need to monitor. So how many errors will we see? If this number is non-zero, let's say 2, we will have to investigate, right? Assuming that we have done our Docker implementation, all that, there shouldn't be any more NTFC download errors. So therefore, this number should be 0. If it's non-zero, we really have to find out what's wrong. Another thing that we need to watch out for is compile errors. So compile errors are within the control of a developer. If we see some compile errors that happen persistently, so let's say 20 compile errors, this is quite serious. It means that our developer is triggering a lot of rebuilds in our Nutex main repo. It's wasting a lot of GitHub runners. So this should be flagged out for manual intervention. My suggestion is that if we see a lot of compile errors, we should put the PR into draft mode. So I mentioned that we will have a process that will run maybe on my computer, right? So this will repeatedly look for draft PRs. If it sees any draft PRs, it will fetch the jobs that are running for draft PRs. If it sees that any GitHub jobs are running for this PR, it will kill the jobs. So this is running on my computer. It's a bit, it's a bit rough, but it might be effective, right? It's something running on outside of our Nutex CI system. We keep scanning for draft PRs. If we see any draft PRs and they are running GitHub jobs, we will kill them. We have done something similar like this before, and I know that it works. So therefore, we can do this again. And after killing a job, of course, we also post a comment, just to inform politely our developer that we killed a job, right? Right. So once the developer has put this in draft mode, and we have this thing that kills any jobs running in draft mode, what we expect the developer to do is that our developer, yes, they can go on and fix the coding error and push a commit, and that's fine. Once they push a commit, it will not trigger any more rebuilds, because we have this thing happening, and the PR is still in draft mode. But once they push the commits, they should be able to use this method here to build and test the PRs in their own repo. So they may do this as many times as they want. If they need 10 times or 20 times to retry the manual testing of PRs in their own repo, 10 times to fix the code, that's okay. The PR is still in draft mode. We should not trigger any build jobs for PRs in draft mode. So hopefully this means that we will conserve our resources. We will not be able to use so many GitHub runners just to fix these 20 compile errors, right? So yeah, if we are seeing very few compile errors, so let's say if we are just doing 2 or maybe 3 compile errors, we'll let it go, right? So if it's happening too often, we are wasting a lot of resources. we will have to do something about it. Yeah. So, for example, one of the PRs that we've seen earlier, this was the second most extensive PR here. This particular PR had a lot of compile errors. We counted at least 10 compile errors. And we hope that this needs to be fixed when we monitor this. So the idea is that when we see this PR running, if this PR were to run again in future, and our developer had to make 10 10 code changes resulting in 10 compile errors, well, we will see this as 10, right? And this will be flagged out, and we will activate this mechanism. The developer needs to switch the PR into draft mode, but then we have a script here that will kill any jobs running in draft mode. So it's not the fault of the developer. This happened way back in January. We did not have this new nice way of running testing PRs in our own repos. But now that we have it, we should really encourage all developers to use it. And developers who don't use it, we will have to flag them out using this kind of a dashboard, and and do this funny mechanism of switching to draft mode and doing retries. Yeah, the idea here sounds a bit rough, but you get the idea. We need to work on this a bit more and figure out what's the best way to do it. Ideally, this would have been done automatically within the Nutex CI, but we are quite afraid to break anything in Nutex CI. It's mission critical. We cannot afford to break anytime. Therefore, I still think right now that I'm more comfortable to run this as an external process running on my computer, which will scan for draft PRs, look for jobs, and kill them. This is the safest approach, I think. So work needs to be done on this new dashboard, Nutex status dashboard, I'll call it. We need to see in real time. This will auto-refresh for every single PR that's happening right now before they are committed. How many builds are they consuming? How many downloads errors are they hitting so far? How many NTFC errors? And how many compile errors? So we'll probably use some color coding. So this 56 will be red, for example. How are we going to use this? We'll use this to monitor any kind of rollout for changes to this Nutex CI. We will also use this to monitor peak periods, right? So if we see that any particular PR is experiencing too many builds, we have to figure out and fix it and understand why they're failing. Is it because it's due to download errors? Then in which case our retry mechanism might be failing due to some reason. We have to investigate. Is it due to NTFC errors? We have to go in and fix it, right? Worst case, I don't know, we might even have to disable NTFC and CI tests for the time being until we resolve this, because this could seriously affect our GitHub runners and maybe even lead to ASF team terminating our access to GitHub Actions. Compile errors, yes, this needs to be done with manual intervention. If we see too many compile errors happening, we have to remind the developer, please switch this PR to draft mode, make changes to your code, test your PR with this manual way of building in your own repos. And in the meantime, I will have to come up with some kind of process which will monitor for draft PRs and kill any build jobs that are associated with this draft PRs. Why do we need this job here? Well, if we don't have this job here, our developer will make changes. It will push a new commit to the PR, and our Nutex CI will automatically build them. So that's why we have to kill any build jobs that are associated with draft PRs. It's not very elegant, but we will have to do this for now because it seems to be something that we are doing with the least risk of breaking our complex Nutex CI system. How will we implement this? Probably the same tools that I'm familiar with. Today we built Nutex dashboard with Grafana. Grafana is an open source tool that will do dashboards like we see here. But there is a data source that is providing the data. And the data source that's providing all this data is called Prometheus. Prometheus. Yes, the the mythical legend of the Barrel of Fire. So Prometheus works like a database. It's actually more of a non-structured. It's more like a JSON database that is typically used for monitoring. We record the status of things. We will use the Prometheus database to record all the PRs and the status. Grafana will be the one to render the dashboard, so we'll see a live updating dashboard based on the data provided by Prometheus. How will we update Prometheus with all our PRs? We will have, yes, another process. So this will be a batch job running somewhere. I think we'll probably put this on Google Cloud. Today we're running our NATEX dashboard on Google Cloud. So yes, I have to pay for another cloud server, which will run this process, which will ingest all the PRs from GitHub, ingest all the job status, and push all this data over into our Prometheus database. So our Prometheus database will be able to render PRs and a job status inside a Grafana dashboard, and we'll see this. Yeah, so this sounds very complicated, but it's necessary because when these things happen, we were stuck. We were all mystified. We are wondering why exactly are our PRs taking so many jobs and running so many jobs with so many GitHub runners during a peak period. And we were blind. We were not able to find out why this was happening. It's time that we did better monitoring. We need a dashboard like this in real time to figure out what exactly is happening in our PRs in real time, and so that we can also see what exactly is happening for our PRs and investigate why these things are happening, whether we are having too many rebuilds, download errors, NTSC errors, or compile errors. So most of these things we hope to be automatically resolved due to our retry mechanism, but some of this will require manual intervention, right? So this will be, unfortunately, we'll need some kind of a human to trigger this part. So likely this will be some NATEX maintainer reminding our NATEX developer, hey, we're hitting a lot of errors. Can you please switch this to draft mode and change the code and retest on our own PR before we change this PR back from draft mode into ready for review. Yeah, there's going to be a lot of work, but it needs to be done. And also, we are making changes to NATEX CI. We will have changes for our retry mechanism. We will have changes for NTFC. These changes are non-trivial. We need to monitor them when these changes have been rolled out to production. And I think this dashboard is a good way to monitor if these things that we roll out are really working or whether they're giving more headaches. Right. So that's our discussion for today. We have studied quite a lot of jobs already. We've done 3 jobs, and I fear that some of the other jobs may be a bit too old to look at. Like, for example, this 4th most expensive PR happened in December. I suspect most of the logs may have disappeared by now. But what I'll do next is that I'll look at this PR. This PR happens in January, and it's from the NATEX apps repo. So this will be our most expensive NATEX apps PR. This is the PR in NATEX apps that consume the most time to build during our peak period of January and February. And it'll be interesting to see what happened here. We want to understand if this PR had to go through so many rebuilds because of download errors, because of NTFC errors, or just due to compile errors. So stay tuned to that. I'll update that and then I'll put that into the next video. Meanwhile, all the links that I've presented today, I'll put it in the video description. Please refer to them. Thank you so much.